Now I can show you how to generate morphing animations of growth. So MorphoGraphX 2.0 introduces deformation functions. So given a set of landmark points in two different meshes, a deformation function is able to map any points of mesh 1 onto mesh 2. And landmarks are defined by cell and parent labels and can be cell centers and/or junctions of the cells. And deformation functions typically have a good accuracy for points close to the provided landmark points and lower quality for the ones that are further away from the landmarks. And when creating a deformation function, the best results are obtained by providing as many input points as close to the region of interest as possible. However, having too many points can make the creation of the deformation function slow. So to create a deformation function, you have to load first the two segmented mesh that need to be mapped into mesh 1 and mesh 2. And we can open actually the Arabidopsis leaf. Okay. And mesh 1 has to be the earlier or parent mesh, while mesh 2 is the later mesh with the parent labels. Okay. So of course you have to have the parent labeling in mesh 2. So when you tick parents, it needs to be everything colored and corresponding to the mesh 1. And now you can activate stack 1 and go to process, mesh, deformation, mesh 2D, create deformation cell surface. So you can specify the direction of the deformation, active to other or the other way around, and which landmark points based on the parent labeling will be used. So you can use cell centers, cell junctions, or both. Cell junctions are automatically found based on the cell parents and are only used if they are uniquely defined. That is, junctions between cells that are all parent labeled. And the parameter junction merging threshold, this one here, specifies the minimum distance between two junctions. So if two neighboring junctions are too close, they will be merged into a single point to prevent the creation of local artifacts or instabilities due to noise. And also the CG step, the conjugate gradient parameter, specifies how the system of equations that define the deformation will be solved. So a value of -1 like this one creates an exact solution, so the system will be solved directly, and a value equal or higher than 1 creates a conjugate gradient approximation of the solution with the number of steps specified. So, but using -1 is recommended unless the solver fails or takes too long to compute a solution. And in such cases, the CG step between 5 and 50 are usually sufficient to produce a good approximation of deformation. Okay, let's run the process. Now the deformation is created and saved into the attribute map implicit deformation of mesh 1. Now run deformation save or export and save the deformation, give it a name like call it deformation, and remember to save also the CSV file with the same name, so deformation as well. And now you can go to morphing, create morphing, and you can give the name of the ID of the attribute map that we just saved. It's called deformation. And of course you can create a growing animation using different time points by saving the deformation functions as different IDs. You can have a bigger animation, and you can try it later if you have some time to load the parent labels corresponding to T1 to T2, then save the deformation, T2, T3, save deformation, and so on. And then you can put all the different attributes here, and then you will see deformation for all of them. And if the two samples are too different with their shape, then it's good to run the process set origin to avoid some of these translation and rotation problems by setting few cells or vertices as origin that will not move. And remember that when you use more than two meshes, it really prefer to manually orient and position each mesh and save them, checking transform in the saving dialog window. So now you can hide the mesh 2. We can select growth and we can run the process. And the process takes the previously computed positions, interpolates between them, and displays the morphed mesh on the screen. And the parameters in the process control the number of intermediate interpolated steps, pause duration after every step, if a heat map is visualized, and then if a spline function is used to produce smoother animations. And now the growth animation is done. And remember, if you want, you can always save the animation when you're running it using record movie. And then you will be able to save it as a set of JPEG images or other set of images, and then you can put them together with FFmpeg or another software to make videos. And I can show you now a growth animation that was done on these samples from T2 to T5. And this was also saved as a set of images and then assembled with a software.